All right, so the band of stability is a plot of stable isotopes comparing protons and neutrons. The band of stability is a plot of stable isotopes. It's a plot of stable isotopes. Right here I've got stable isotopes comparing protons and neutrons because we're talking about the nucleus here. Okay? So what we're going to do is we're going to make this axis down here what we...
What's the top of the chart?
We're going to have each of these large graduations to be 10. So we're going to have protons down here, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay? And what we're going to be plotting on this side right here will be the protons in the nucleus. Right. And then we're going to, on this axis, we're going to be plotting neutrons in the nucleus, and we're going to have the same graduations, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 140, 150, 160. And this is the neutrons in the nucleus. Did I? Oh man, I sure did. 130, 140, and 150. Okay. Not sure why I did that. Oh well.
You want to be a rebel?
Maybe so. That's probably right. Now, you might want to use both pen and pencil for this. It's up to you. Okay. The first thing you want to do is have a guideline. This is not the actual graph, but a guideline for our graph, okay, or for our plot. And this guideline needs to be where x equals y. What kind of line do you have when you have x equals y? No, it's not like that. That's where y equals 0. Vertical is x equals infinity and x equals a number and y equals infinity. What kind of line do you have when x equals y? If x equals y and I go over 10, how much do I go up? Yeah. If I go over 10, how much do you go up? Yeah, up 1 over 1. So if I go over 10, up 10. If I go over 20, up. If I go over 30, up. Okay, so that's x equals y. So you need a guideline where x equals y. So if I go over 80, I need to go up 80 right here. Okay? So there's your guideline. Okay? Now you have to have that right. Okay? You can't just stick some line on there and expect everybody to know it's x equals y if it isn't actually x equals y. But what is x? Okay, and y is neutrons. So this line is not really x equals y, and I've got it off just a little bit anyway. Let me erase mine and put mine back on the correct location. Okay, so there's x equals y, and I'm going to label that because it's not really x, it's protons equals neutrons, okay? So I'm going to label this line as protons equals neutrons. That's up to you. How you write it's up to you. I'm just saying that this is your guideline, okay? But you can also write as P plus equals N because that's the symbols for protons and neutrons, okay? All right, your next guideline needs to be your next guideline needs to be where x equals 1.5y. X equals 1.5y. So if x equals 1.5y, if x equals 1.5y, if x is 2, what's y going to be? 3. If x is 20, what's y going to be? 1.5 times 20? Not 15. That would be if x is 10, this would be 15. 30. You understand that? Alright. So we want a line now where you go over 20 and up 30. Over 20 more and up 30. That's your next guideline. Over 20 and up 30. Over 20, up 30. Up 30. Over 20, up 30. So that's your next guideline. Over 20, up 30. So this guideline then is where protons, that's x, equals what? 1.5 neutrons. So protons, or P plus, equals 1.5 N for neutrons. Okay, that's our next guideline. What, you go over 20 and up 30 and put a dot there. Over 20 and up 30, put a dot there. Over 20 up 30, put a dot there, and then connect the dots. Yeah. What? P plus for protons. Proton symbol is P with a superscript plus equals N for neutrons. Okay? Now we want a line where X equals 83. Yeah. What kind of line do you have when x equals 83? What does it look like? Vertical. You just have to find 83 and make a vertical line. If x is 83, you have a vertical line. So if this is 80 and this is 90, there are 5 graduations. What is this mark right here? 82. If there's 5 graduations between and a 10, that'd be 82. What's this one? And where would 83 be? 82, 84, where's 83? Right there in between. That's it. So you want a vertical line at 83. Alright, now why did I do that? I did that because the last stable isotope, the last element with a stable isotope is bismuth, number 83. So our stable isotopes are going to stop right here. Okay? The last element with a stable isotope is bismuth, number 83. So since we're plotting stable isotopes, our plot has to stop at 83. Does that make sense? Alright, just to make it easier, we also need a vertical line where x equals 20. A vertical line where x equals 20. Okay? So this vertical line, this is our stop line where protons equal 83, or P plus equals 83. Okay? And this vertical line here is protons equal 20, or P plus equals 20. 83, because the last element with a stable isotope is number 83, which is bismuth. if we're plotting stable isotopes, we can't go beyond 83 because there are no stable isotopes beyond 83. Does that make sense?
So what does it say next to that one?
Here, protons equals 83.
And is that line on 81?
No, this line is on 83.
What's the other one say? Yeah, what's the other line?
Right here, protons is 20.
Wait, why did you make that line on 20?
I'm going to show you that next, so just bear with me on that one. Okay, these are all our guidelines here. So you need to know these guidelines. Protons equals neutrons. Protons equals 1.5 neutrons. Protons equals 83, and protons equals 20. Okay? And if you have these guidelines, then we can figure out, generally speaking, where the stable isotopes are. Because between element number 1, which is hydrogen, and element 20, isotopes are stable when protons roughly equal neutrons. Between element number 1 and element number 20, isotopes are generally stable when the number of neutrons and protons are roughly equal. So that's what this line is right here. As long as I'm on or close to this line right here, I'm probably going to have a stable isotope up to element number 20. Okay, up to element number 20, as long as the protons and neutrons are roughly equal, you're going to have a stable isotope. Okay? Now, after this point right here, there's a slow, smooth curve up till we intersect right here, where protons equals 83 intersects with the line protons equals 1.5 neutrons. So protons equals 83 is this line, protons equals 1.5 neutrons is this line, and so we're going to have a slow, easy curve up to that point. So almost, because it's easier for me to do it since I'm right-handed, to spin it around, I'm going to just spin it around like this and make a slow, easy curve from here to here. Whoops, I almost went off there. And that's what the band of stability looks like. It starts slowly turning northward here, right in here at where x equals 20. Okay? Okay, 1 second. Alright, so is an element with an atomic number of 50 and an atomic mass likely to be stable? Well, let's look. So atomic number 50, that's the protons, that's down here. So atomic number 50 is right on this vertical line here. Okay? So we've got atomic number 50. Okay, and what we want to do is to find out where it intersects with the mass of 130. Okay? So I'll just hold this line right there. Alright? So if I have a mass of 130, how many neutrons do I have? That's what I have over on this vertical axis, neutrons. How many neutrons do I have if the mass is 130 and the atomic number is 50? 80. Because protons plus neutrons equals atomic mass.
Oh, or you can just like connect it to 130 and then go across and it leads to 80.
I don't understand that. You got to know that it's 80 when you get there. So 50 up to 80 is right here. Does that look like it's going to be stable? Well, that's how you get 80. Is if protons plus neutrons equals atomic mass, and so this is 130's atomic mass. Atomic number is protons. That's 50. So what is N?
What?
Yeah.
50 and 130. When you connect them, it leads there. If you go straight across, it leads to 80.
Huh. I would have never thought about that. I see what you're trying to do. Okay. All right. So N equals 80. So if I go up from 50 and hit 80, is that a stable isotope?
Nope.
No, because it's not near. There's the stable ones down here. That's not going to be stable there, is it? Okay. Let's see here. How about we use? How about calcium?
You can't do it, right?
Calcium. Um, 16. Is calcium 16 going to be, actually I don't want 16, let's do 26. Is calcium 26 going to be stable? I didn't say pack up yet. I didn't tell anybody to pack up yet.
No. Yes. No.
If it's only a yes or no answer, and I guess you say both of them, you know, you're going to get there if everybody guessing, right? All right. So what is calcium's atomic number?
20.
P plus equals 20. Okay. So the N equals what? What's the number of neutrons going to be? 6. And so 20 protons and 6 neutrons is right here. That's nowhere near stable, is it? I know, but you said yes as well, so I wasn't sure. All right, so we wrote down the homework earlier. Make sure you don't forget that. Thank you. Uh-oh.